So as mentioned, this is the workshop for the revised Stormwater Post-Construction Best Management Practices Manual. This manual is a statewide document, and we also had participation from Department of Transportation on Maui in redeveloping this manual. And to kick things off, I will let Karen give us an introduction.
Thank you, John. Good morning, everyone, and thank you for attending our revised post-storm construction BMP manual workshop. What is this workshop about? It's going to provide you procedures and guidelines to ensure that our post-construction BMPs are considered and implemented as applicable throughout all phases of our DOT-HWYS new development, redevelopment, and private construction projects. When the manual we already completed as stated, and we want to implement it this year. DOT-HWYS is going to train you today and next week, Wednesday, as John stated, on what you need to do in order to use the manual. John, I believe the implementation date we chose was this summer, but you can go into that when you do your presentation. The why we're doing it is because we have organizational changes in the structure of the manual to increase clarity and improve your ability to use it. We want to separate our post-construction BMP criteria for areas under an MS4 NPDES permit and more rural areas that are not covered under a permit. We revised the criteria for MS4 NPDES permit areas to increase the implementation of these post-construction BMPs, prioritizing our LID BMPs as well. We revised the evaluation process to determine whether a project qualifies for a variance from the LID BMP requirements or an exemption from the post-construction BMPs, an alternate compliance process for projects which the full required treatment area cannot be addressed by the post-construction BMPs will be covered today. Next slide. So where do you find this manual? The revised manual is available for downloading at stormwaterhawaii.com. And there we go. The effective date we chose is going to be July 1st of this year. What are we going to cover? We're going to cover what's in the manual. The first section is our environmental background and an introduction. Second section is stormwater post-construction BMP practices. Third is the criteria for MS4 permit areas. Fourth is the criteria for non-MS4 permit areas. 5 are exemptions and variances. 6 is the alternate compliance. 7 is the post-construction BMP design methodology. 8 is the post-construction BMP development in your planning phase. And 9 is in the design phase. And here we go.
All right, thanks, Karen. So yeah, let's get into this. First of all, what is a post-construction or permanent BMP, and what is LID, low impact development? So a post-construction BMP, it's a specific practice intended to reduce stormwater volume and or the pollution typically associated with stormwater runoff. Such practices may include LID, low impact development design features, source control methods, or manufactured devices designed to capture pollutants, and is synonymous with the terms permanent BMP and permanent post-construction BMP. That's one of the things we tried to clarify across our new stormwater management program plan and this manual specifically is the terminology. You often will hear permanent BMP, permanent post-construction BMP, or just post-construction BMP. So we're going with post-construction best management practice, but again, it's if you hear permanent BMP or permanent post-construction BMP, basically the same thing. And low impact development is really the BMP of choice, and that's more taking into account land planning and engineering design approach with the goal of maintaining and enhancing pre-development the hydrologic regime of urban and development watersheds. So we'll get a little bit more into those specific techniques shortly. So first off, getting into some of the things that are different with this manual than the previous version of the manual. So the term public versus private construction project, those are new terms. In the previous manual, public contracts were called contract projects, and private projects were previously called encroachment projects. And the terms public and private seemed to be more clear because if there's the contract project used to refer to projects that were fully funded by DOT-HWYS and located in DOT-HWYS right away. So those projects are always going to be public projects. And those are either constructed by DOT-HWYS or private contractor. Private contracts, or previously called encroachment projects, they're a project that are not under the authority or funding of DOT-HWYS, and it's located either within or adjacent to DOT-HWYS right away and drains to the DOT-HWYS MS4, or even if it just drains to the DOT-HWYS right away. It's not necessarily a privately funded project. It could also include City and County of Honolulu projects. Private construction projects are required to obtain a permit to perform work upon state highways if they do encroach into the right-of-way. Private construction projects that drain to DOT-HWYS MS4 or right-of-way are required to submit an application for private storm drain connection and or discharge permit to the state of Hawaii. And just reiterating, also known as encroachment projects or encroachment contract projects. Okay. So what are some examples of LID treatment control? But these will be your vegetated buffer strips, vegetated swales, enhanced swales, infiltration trenches, infiltration basins, bioretention facilities, permeable pavement, pocket wetlands, rainwater harvesting, tree box filters. I just want to point out too that we're not all inclusive in all the possibilities here. We're just pointing out and providing some of the more common types that have been used in the past and that are suitable for Hawaii. But if you have something, technology is always changing, and you can also be creative based on your specific site conditions. You don't have to necessarily choose one of the options that's provided in the manual. Here's a cross section of bioswale or enhanced swale. This type of swale is considered an LID treatment control because it provides infiltration. You can see the cross section there. It has the surface layer of grass or native plants to provide the initial filtering and velocity reduction, and then an engineered soils layer, and then an aggregate storage layer for stormwater during heavier events so that it has time to infiltrate. And then, sorry, I just got a message. Just check. And then usually it has like an underdrain system for overflow water to go to the stormwater system. This is another type of LID. This is actually a treatment train that was installed under H3 in the Kaneohe area. And it actually starts with a surface swale and then hits this riprap splash pad to slow velocities before going through a settling basin. This gets most of the sediment out before it spills into this bioswale with underdrain system. And the advantage of this kind of system is that it takes out the fine sediments prior to entering this bioswale, which is going to increase the life of that bioswale so that the infiltration rates won't be reduced by fines filling in the engineered soils layer. If we cannot accomplish an LID treatment control type BMP, then the next method is non-LID treatment control BMPs. Some examples of these are a wet pond, a sand filter, wet extended detention pond, drain inlet filter, modified catch basins, oil grit separators, centrifugal hydrodynamic separators, multi-stage hydrodynamic separators. Over on the right here, this is an example of a proprietary unit. We've got quite a few of these installed on the island. This is a continuous deflection separator or CDS unit. These have the advantage of taking up a much smaller footprint than LID. So they're definitely areas where we have constrained right of way and we just can't meet the requirement with LID. So this type of unit will be an alternative. Another type of non-LID treatment control are these debris separating baffle blocks or water polishers with up media filters. These can be, we have these in ranging from 5 by 10 foot squares to 20 by 30 foot by 20 feet deep. They can be sized according to the amount of runoff, so they're scalable. And they can be used like at the end of a long run of inlets to treat a lot of stormwater. And while they are expensive, someone just asked if the PowerPoint slides will be available for download. This session is being recorded. Sorry for the interruption. And you can view it later. And I'm not sure if we'll provide the slides. I believe we probably will. We'll get back to you. So the advantage of this is you can treat a large area, and it only requires maintenance maybe once or twice a year. The disadvantage, it does have a lot of upfront construction costs. So it's going to be expensive to install, but it's going to get you a lot of treatment for a longer period of time. These can also be installed with a water polisher media filter included or as a totally separate device. We do have 2 of these on the island right now. If you need to get rid of, if you're in a watershed, like a TMDO watershed where you need to get rid of really specific nutrients or dissolved nutrients, this system provides filtration, and you can specify the type of media you're going to put in here to specifically target the nutrients that you're trying to reduce. Some other types of devices that we've been using, downspout filter box. There are a lot of sections of the freeway, especially like H1 over by the airport, where the freeway's up on an elevated viaduct. And so there are a lot of these downspout filters that typically we're just flowing straight onto the ground and either into nearby waterway or into a nearby storm drain system. So an option is to put in these concrete filter box, and with this screen system that filters out and allows water to flow out through the screen or through the overflow while trapping all the sediment and trash from the freeway above. And then another device are these curb inlet screen guards. These are typically more for trash reduction and trash capture. This particular design has a gate that will open during high flow events to reduce the risk of flooding. These can also be installed in combination with a basket inside the catch basin that filters out fine sediments and also will capture anything that flows through during a high flow event if these grates are triggered to open. We also encourage source control BMPs. These are just management techniques and tools that reduce stormwater runoff and pollutants at the source. So this is like land management techniques, soil stabilization, so just keeping the sediment from even mobilizing so it doesn't have to be trapped in a BMP, stormwater flow control methods, trash management practices, keeping providing a facility for your trash bins to be covered so they don't have rain and stormwater flowing through them, causing pollutants to come out. Just general good housekeeping measures and spill prevention techniques. So let's say you get to the point where you've decided you're going to design either an LID or a non-LID treatment control. This manual, Appendix A, has some examples of the more common LID treatment control and non-LID treatment control methods that we've been using on the island, and then also some proprietary non-LID treatment control methods. And this table is also provided to give you some insight into the types of pollutants that the various BMP techniques target. And again, this is a guide, and this is just put you in the right direction and provide you some resources to get your design started. But it's not meant to be all inclusive of every potential option that you could use as a BMP. And just to go through one example, if you were to want to design an enhanced swale, you would go to Appendix A15. And I'm not going to read through all this, but I just wanted to show you the types of detailed information that's available here. Again, it gives you that information up here that tells you which sorts of pollutants that this BMP will target, description and purpose, application, limitations, and then you're going to get into your design criteria. And it provides you the sizing procedure that meets the requirements of the DOT's stormwater manual. I did see someone raise their hand earlier, and I'm just going to point out, if you could just please send your questions to the Q&A, that would be appreciated. So this talks about pre-treatment, and on to the next slide. This is more information about the design criteria for an enhanced swale, giving you information on how to calculate the total area required for your swale, additional design parameters, and then also some pre-treatment considerations, like that treatment train that I showed you earlier. That was the surface swale, and the settling basin was a pre-treatment for that bioswale. And then construction considerations, landscaping, maintenance and inspection, and then some design details. So again, that's just one example of the information I provided in Appendix A to help you get started on your design. So as mentioned up front, the new manual provides two separate criterias. One is for areas that include MS4 permits, MS4 and NPDS permits. And that would be the islands of Oahu and Maui. All the other outer islands do not include MS4 and PDS permits. And so these criteria don't apply to them. And in general, the criteria of the previous manual is still the same criteria that the outer islands use. And I'll go through that as well. But I'm going to start off describing the criteria, the new criteria for the MS4 permit areas. So these are revised. Previously, the trigger was if your project included 1 acre of new impervious surface, that was the trigger to require you to implement BMPs. The new criteria is if your project just results in 1 acre or more of disturbed area, then you are required to implement LID BMPs. And then also priority projects that have high potential for pollutant discharge may be required to implement post-construction BMPs at the discretion of DOT-HWYS, regardless of the amount of disturbed area. So these include things like gas stations or parking lots where they're just 100% impervious. And there's a larger list of those types of projects in the manual. Something to point out, the definition of disturbance for the post-construction BMP manual is a little bit different than for construction. For construction projects, if you're going in for a construction NPDS permit, you are required to include your staging area. Even if that staging area is on a paved surface, that is considered disturbed area. So for post-construction BMPs, you do not have to include that area. Disturbance is actually it's only areas that are actual disturbed. Any construction-related activity that results in penetration, turning, or moving of soil, including roadway construction, demolition, grading, grubbing, and reconstruction of pavement, which exposes the underlying base course or bare soil. So if you're doing a cold plane and you don't expose base course, that does not have to go into your disturbed area calculation. But if you get down to base course, that is considered disturbed area. Disturbance does not include clearing that leaves soil intact, nor does it include operation of vehicles, staging, and storage of materials and equipment on paved surfaces. Just to back up, that was the criteria for public construction projects. So these are projects in DOT's right of way owned by DOT. For private construction projects in MS4 permit areas, you're still held to the trigger. If you have 1 acre of disturbed, you're going to definitely trigger the requirement for LID post-construction BMPs. But the DOT also may require at their discretion, regardless of the project size, that you include post-construction BMPs. And that's just taken on a case-by-case basis. But basically what DOT is looking for projects that are outside of their right-of-way, but drain to their right-of-way, they want to see no net increase in flow off of that project. And so if you do have an increase in flow volume resulting from your project, they're going to want to see on-site LID or non-LID post-construction BMPs that treat that additional runoff. And then another point at the bottom here is just that projects that are located or drained to sensitive receiving waters. So those are projects that are in total maximum daily load watersheds or watersheds with waste load allocations or on the 303D list, which I'm going to get into in a little later if you're not familiar with those terms. But those projects are more likely to require post-construction BMPs no matter what size they are. So now going back to the non-MS4 permit areas. And again, this is really in line with what the previous manual's criteria was. And so that is that all public construction projects that result in 1 acre or more of new impervious surface are required to implement LID BMPs and or non-LID BMPs. And then again, priority projects that have a high potential for pollutant discharge may be required to implement post-construction BMPs. And again, that's your gas stations, parking lots, and other highly likely type projects that may discharge pollutants. Private construction projects in non-MS4 permit areas are held to the same standard. They're required for private construction if 1 acre or more of new impervious is created within DOT-HWYS right-of-way. And in non-MS4 permit areas, DOT isn't, they're not as likely to be able to hold you to post-construction BMPs being required, but they're highly encouraged. And we definitely would hope that if there's an opportunity that post-construction BMPs would be included in those projects. And then again, public construction projects, even in the non-MS4 permit areas that drain to sensitive water areas, are more likely to be required to include post-construction LIDs. Okay, so we have these very handy flow charts to help you through your decision-making process in MS4 permit areas or non-MS4 permit areas. And as much as these are an attempt to account for most scenarios, there are always going to be unique scenarios that don't quite fit within these flow charts. So they're a good guide, they're a good starting point, but we do understand that there may be unique situations where you need to reach out to DOT and say, hey, my project doesn't exactly fit in this flow chart. But if you walk through, you can see is like for a MS4 permit area, you've got, is the project a private construction project? If it's yes, then it's, okay, this is actually a really good point that I had meant to bring up earlier. But for private construction projects in MS4 permit areas, they're almost always going to, especially on the island of Oahu, and I think on Maui as well, they're almost always going to be subject to the city and county of Honolulu's rules. You're going to trigger their stormwater management requirements before you trigger ours. And rather than have you produce two separate reports and try to comply with two separate criterias, the Department of Transportation will accept your city and county design report as long as it complies and is approved by city and county. So, and then if the project is on private property and it doesn't discharge to DOT right away, then the next evaluation is the project a priority project or drain to sensitive receiving waters? If it's no, then as far as the state's concerned, post-construction BMPs aren't required. However, you will probably still be required per city and county rules. If it does not discharge to DOT-HWYS right away, but it is in a sensitive receiving water, then DOT will still encourage or potentially require you to include post-construction BMPs. But again, that's going to most likely be covered by your city and county requirements. Another scenario, if it's not a private construction project, and then does the project only consist of exempt activities? That's something I'll get into a little later, our exemptions. So if it's a DOT public project and it's exempt, then you're exempt from post-construction BMPs. If it does not consist of exempt activities, then the next question is, does it disturb an acre or more? If it's yes, then you ask, do existing post-construction BMPs treat the required treatment area? And most likely it's going to be no, because this is a fairly new program to require these post-construction BMPs. So then you've got to install LID BMPs to the MEP, maximum extent practical. If LID BMPs can't be installed due to space constraints or other issues, then you'll be required to install non-LID BMPs. Yeah, someone commented city report should take into consideration the discharge into the state MS4. And that is, that's what we're asking for. We've had a few scenarios where a project is private and it triggers city and county, and then there's maybe a small portion of the project that's in DOT-HWYS right away that required like maybe a turn lane be added or changes to the sidewalk that resulted in a small amount of new impervious in DOT's right away. And the applicant was attempting to do separate reports for, or trying to account for that separately from city and county. We would prefer that you just account for all that stormwater runoff in the city and county's report. It is at your discretion if you want to do two separate reports. We're not going to stop you from doing that, but it's more efficient for everybody if you just handle all that in the city and county report. And an alternative to even treating the stormwater in DOT's right away is to calculate that additional flow that's generated from the impervious in DOT's right away, and then treat that additional area on site. And we would accept that in most situations, rather than trying to treat it in DOT's right away. We also would try to discourage if you can treat it on site, it's better than having to install a treatment device in DOT's right away, because that creates issues with future maintenance. It would require a maintenance agreement and an easement from the private landowner to go onto DOT's property and maintain that BMP. So we like to try to avoid that scenario. So two different flow charts, one also for non-MS4 permit areas. Hopefully these are useful and get you on the right track. But again, if you go through this and you don't feel like it meets your specific circumstances, you'll have to reach out to DOT and they will help you figure out where your project fits. So as I mentioned, there are exemptions and variances. And so one of the more, gotta go back. One of the more obvious ones are projects that do not result in stormwater discharge into the MS4 or state waters. That's pretty rare. If you've got a project, I mean, the water's going to go somewhere unless that happens to be in the center of a crater. The other types of projects that are exempt are operation and maintenance activities. So that's just like structural repairs, base yard maintenance and repairs, installation or replacement of pavement striping and pavement markers, pavement preservation treatments. So pavement resurfacing, restoration, or rehabilitation projects in which improvements are confined to the impervious pavement layers, such as pavement overlays, cold planing, crack sealing, or similar treatments. Guardrail and underground utility projects. So if it's, like board of water supply, replacing a water main down the middle of DOT's right of way, that is considered an exempt activity. And then in addition to other types of utility and installations and relocations. Other exemptions are water quality improvement and preservation. So there are some projects that the environmental group where the whole purpose of the project is just to improve erosional areas or to install a stormwater treatment system. And that's the whole point of the project. So obviously we're not going to be triggering the stormwater manual for that. Landscaping, culvert rehab or replacement, installation of post-construction BMPs, erosion and sediment control, rockfall mitigation. Minor disturbance projects such as replacing signs, upgrading ADA ramps, bridges or roads constructed above or below existing impervious surface. So if you're working underneath the H1 viaduct, pedestrian walkways or bicycle paths, or emergency projects, temporary projects, or projects that are currently in design phase in which timing and scheduling of the project for advertising may make it infeasible to comply with the revised manual. So that's more going to the point that this revised manual goes into effect on July 1st. And there may be projects right now that are at 30% design or 90% design, and they're technically not going to be completed until after July 1st. If the design is already underway, they will not be required to comply with the new manual. They'll only be held to the previous manual. So this is really only for projects where the design phase starts after July 1st, 2022. And then also federal aid, city or county projects are exempt. So here is another new aspect of the revised manual. This is the alternative compliance. And what this does, it's basically a strategy that allows post-construction BMPs to be implemented in alternative watersheds. And it's allowed when a project cannot adequately treat the full required treatment area. That would be normally required for the amount of disturbed area and impervious surface. And DOT-HWYS will identify an alternative watershed of similar or higher priority in which to provide additional water quality treatment. And I'll get into that in more detail shortly. And this provides flexibility for MS4 permit compliance. There are scenarios where it just isn't feasible to comply with the LID or non-LID treatment requirements for a project, but we still need to comply with the MS4 permit, which requires that treatment. So this is an attempt to come up with an approach that helps DOT stay in compliance while also recognizing that every project's not going to be able to fit these treatment devices. And then another advantage of this is that potentially, a project that can't meet compliance might not be in a sensitive watershed anyway, and we could potentially move that alternative compliance to a watershed that is in like a 303D or sensitive water body. Smaller post-construction BMPs from multiple projects may be combined into a larger single treatment device. So if you have one project that's linear and might require multiple BMPs to treat the stormwater along the alignment, the alternative compliance could allow a more efficient system to be installed elsewhere to treat that volume, and improved economies of scale in administrative, construction, and maintenance costs. like to point out too, currently this is only an option for Oahu projects. Maui is not going to consider allowing alternative compliance at this time. They're going to push you to meet compliance with the LID or post-construction B compliance within your project footprint. So here is a decision-making tree to help you determine if your project is eligible for alternative compliance. So first of all, have you installed LID BMPs to the MEP? That's the first goal. As much as possible, we want you to try to meet the LID BMPs requirements within your project. And if you do that and your required treatment area is met, then you go yes, and your project meets PC BMP requirements. If the answer is no, then you move on to non-LID BMPs. And then if with your non-LID BMPs, your required treatment area is met, then your project also meets permanent BMP requirements. And you can see my note up here on the right. Most projects should end up here. We want you to meet the LID or non-LID BMP requirements within your project footprint. The projects that we can see not meeting this are projects that are severely constrained. And again, that's not just horizontally if you're constrained within the right of way, because there are treatment systems that can be installed underground, but you may also have a situation where subsurface conditions don't allow you to install a non-LID system either. So in that case, you would be a candidate for using this alternative compliance. And so in order to request alternative compliance, you're going to submit a variance request form to DOT. And if the project requires additional BMPs, that's going to be tracked in a spreadsheet that I'm about to show you in a few moments here. And again, alternative compliance is going to be in a separate watershed. Let me go see here. So let's go through the credit tracking program a little bit more. So it's measured in units of treatment area. So projects that treat more than what is required will generate a credit. So we actually have some projects, like I mentioned earlier, under some of our other programs to meet waste load allocations or TMDL requirements, where the project wasn't triggered by a new development or redevelopment project, but it was just a project that provides stormwater treatment. So those are already in our bank, and those are credited to us as stormwater drainage or stormwater treatment. Projects that treat less than what is required, they'll generate a debit. So those projects will be basically reducing or taking away from that credit, or even putting the bank in negative territory, and will have to be accounted for in a future project. If a project creates more debits than credits, then the variance request form to justify that, and all other options were evaluated and deemed infeasible. So you're going to have to justify why your project meets the requirements for this alternative compliance. And it can't just be that it's too difficult, or it's too expensive, or we just don't want to do it. It's got to be justified at a reasonable level. And then the documentation will be used to verify program compliance. So just another little definition of credits. Credits, post-construction BMPs are sized to treat an impervious area larger than the required treatment area. Projects result in a reduction of impervious surface. So you may have a project where you're actually taking out pavement and restoring it to a pervious surface, and that could also provide a credit. Retrofit existing highway facilities. So we have under the Stormwater Management Program Plan a retrofit action plan, which is ongoing, where we are going in and just retrofitting structures to treat stormwater in areas that aren't associated with a redevelopment or new development project. So those are creating credits. And then also just standalone post-construction BMP projects to target specific watershed pollutants. Debits projects result in an increase in impervious surface area, and existing post-construction BMPs are removed or no longer provided, and there is no additional treatment added. So let's get into these terminologies of TMDL watersheds and 303D watersheds. So one point, another important factor is that this alternative compliance is only allowed for public construction projects. Private encroachment projects are not allowed to use this alternative compliance. And the alternative watershed must be of equal or higher priority to be identified by DOT-HWYS. So I'm going to go through with you in a moment where you can find that information on DOH's listing of 303D watersheds, but they have them prioritized. And so we've converted the priorities to 1 through 4 in our worksheet, which I'm going to show you in a moment. And the higher priorities are the lower numbers. So priority 1 would be the highest priority watershed. So if your project that requires alternative compliance is being conducted in a priority 1 watershed, then your alternative compliance watershed also needs to be in priority 1 watershed. So this is a look at our water quality sheet. Let me just take a quick moment to look at some questions. One question was, does the 2022 SWAMP supersede all past highway documents? So yeah, the Stormwater BMP manual from 2007, yeah, that one was actually superseded by the 2015 manual. And then the 2015 manual is superseded by this manual as of starting July 1st, 2022. So yes, the previous versions of the manual are no longer relevant after July 1st, 2022, except for projects that were already in design, like I mentioned earlier. Can the credit be used for other nearby projects, or does it only pertain to specific projects that obtain the credit? Hopefully this question will be answered as I go through the water quality worksheet. So I'm going to need to open Excel. Hang on just a minute here. So hopefully someone will yell at me if you can't see my Excel spreadsheet right now. But we're going to provide this spreadsheet to designers if you are seeking alternative compliance. And actually, we're going to provide this spreadsheet to designers whether you're seeking alternative compliance or not. We're going to request that this be filled out. There's also the requirement for a post-construction review checklist, and that's not a new requirement, but the checklist has been updated, and that's something that Jason's going to go through shortly. But really, the information that you need to fill this spreadsheet out is provided on your checklist as well. So it's not really new information, but it's just putting it into a format that helps DOT keep up with their credit tracking system. So basically, you're gonna go through here. You're gonna say which watershed your project is in, and then the watershed priority will autofill. We actually have the watersheds and their priorities provided in the spreadsheet. And then if it's a new development project, you're going to talk about existing impervious surface. This is just an example. In this project, there will be 1 acre of new impervious added. And so the treatment required for new development will be for 1 acre of new impervious. For redevelopment of an existing impervious surface, the requirement is only that 25% of that area needs to be treated. So if this project also has 1 acre of redevelopment, but it will be run through this 25% factor to add up to total required treatment area of 1.25 acres. In this example, a bioretention basin will be used to treat 1 acre. This handy pull down provides most of the types of treatment that you would be using if you do have to use, if you are going to use something that's not covered in here. We can alter the spreadsheet to account for that, but you can just go ahead and select which type of treatment you're using. In this case, the project can only treat 1 acre, and so there's going to be a deficit of 0.25 acres that's going to need to be accounted for. For the designers, this is where the spreadsheet's going to end for you. This part over to the right is going to be something that's for the design reviewers at DOT-HWYS. And the first thing they're going to do is say, was the MEP applied? If they see this calculation and they see that there's a deficit of 0.25 acres of treatment, but then when they do the design review, they don't feel like the design incorporated BMPs to the maximum extent practical, they will kick it back to you and say, you need to account for this 1/4 acre of treatment. If they do feel like the MEP was applied, then they will approve this alternative compliance, and that is something that DOT will take care of on their end. And we'll work with you folks at DOT-HWYS to make sure that you understand how this process works, and we can provide assistance on alternative watersheds. But in this case, you can see if you were to put in, since IAEA is a priority 1 watershed, if you were to try to put in something that's like in a priority 2 watershed, it's going to get, you're going to get error over here. That's not adequate. This is also something just for internal DOT folks. They're going to be able to, we're going to keep track of proposed projects that are going to make up for the deficit on this spreadsheet. And then we also have populated, completed projects that are, that have provided credit. So let's say you've got a project and your first question is, which watershed is my project in? And that's a good question. Most design firms have access to GIS. One way you might find it is just through your GIS system, figuring out where your watershed is located. If you have to fill out a construction NPDES stormwater permit through DOH, that's going to also identify which watershed your project is located in. Another resource is the Hawaii statewide GIS program, and you can go here and we will provide these links along with the spreadsheet when you are filling out this information for your project. But you can go to this GIS system, you can figure out where your project's located. You can zoom in pretty far and find the exact location of your project, and it's going to tell you right which watershed your project is in. Once you know which project your watershed is located in, you're going to go to this webpage. And again, we'll provide you this link. This is the integrated report and total maximum daily loads. And this is updated every 2 years. So the last time the final report from 2020 is available at this link. Right now, the draft version of the 2022 standards are available. And we'll just go ahead and take a look at those. And also I want to point out that, yeah, so this is actually a pretty long report and it has a lot of information in it. And so I just wanted to pull it up to point out that what you are looking for is Appendix C. And you're going to go to Appendix C and you're going to find your watershed. and then it's going to tell you which priority. And again, on the spreadsheet, we've converted these priorities from the low, high, and approved to 1 through 4. And for the most part, you shouldn't have to go to this. The design folks, the people that are designing the project, shouldn't have to get to this point because this information is provided and will be updated in the spreadsheet. But we just want you to know where it comes from in case you need it. And then also the design reviewers at DOT can go here to confirm that the most current version of the 303D list is being used. Back to my presentation. So again, that's basically just the report I just shared with you. That you're going to want to go to the most current version. So at this point, I think we'll give you guys about a 5-minute break, and then let's say at 9:10 we will start up again. But just want to give folks a chance to use the restroom, get some coffee, stretch a little, and then at 9:10 Jason's going to take over and give us some more information, get more into the design aspects. Okay, welcome back. I'm going to pass it over to Jason.
Okay, I'm here. Thanks,
you.
John.
Yeah.
Okay, so can everybody see my screen okay? Takes me a while. The first 2 times I did a presentation, I forgot to click the right button. So hopefully you guys can see that okay. Okay, so I'll be handling the second part of today's workshop. It's kind of like in school. So John was your English/geography teacher, showing you maps and stuff. I'll be your math teacher for today. We'll be going through some equations, basically to show you how to go through the design methodology, how to determine when BMPs are required, how to size some BMPs. And then I'll also cover some of the changes that we made for the planning phase and also projects in the design phase. And then I'll hand it back off to John. He's going to cover some pointers about inspections as well as BMP maintenance. Okay, so some of the...
Hey, Jason.
Yes.
We're seeing your slide. We're kind of seeing your whole, like the presenter's mode, where we can see your little next slide on the sidebar.
Let me try and change that.
That's good.
Okay. Okay. Sorry about that.
Okay. Yep. Thanks.
Okay. I'm still got to get the hang of this. Okay. So some of these things are, some of the things that I'll mention is things that John already brought up, but it's important to bring it up again. So in a summary, this is a transition manual. It's a new manual. So as we transition from the current manual, which is a 2015 version, to this new manual, it's good to know, where we're coming from and then where we're headed. So the current criteria for the 2015 manual, we don't have any distinction between MS4 permit areas as well as non-MS4 permit areas. So current manual has a trigger for LID BMPs to be required whenever you have 1 acre or more of new impervious area created. And the current manual, or the 2022 manual, now we do separate that out. So for MS4 permit areas, once again for Oahu and Maui, the new criteria is that any projects that result in 1 acre or more of disturbed area will be required to implement LID BMPs. And for non-MS4 permit areas, which are the other neighbor islands, there's no change. The criteria stays the same. Okay, and the goal for this is, mainly we want to try and have more projects that spur, LIDs. We want to, be a little bit more aggressive in promoting BMPs and improving water quality. So some of the key definitions, once again, disturbance. It's anytime you penetrate, turn, or move the soil, including any roadway reconstruction, demolition, or the exposed untreated aggregate beneath existing pavement. And once again, this is slightly different from the Department of Health definition for NPDES construction activity permits. So this manual excludes activities that leave the soil intact, and it also excludes any operation of vehicles, staging, and storage of materials on paved surfaces. So these are examples of activities that are not considered as disturbance. Okay, the new term that's also introduced in this manual is this concept of new development. And it's basically just new impervious surface. So anytime you have a new road, any new lanes or road widening, parking lots, it's any new paved surfaces. And the reason why this manual is focusing on impervious is that there's a lot of studies that have been done recently on the mainland. And they're finding that a lot of the majority of the pollutants originate from paved surfaces. So although you have a project that may disturb pervious areas, in the long run, it's going to be your impervious surfaces that generate the most pollutants, whether it's oils and grease, dissolved metals. And so this manual is also going to be taking that same approach. This second part of the sentence where it says it's new impervious surface, which is intended for vehicular use, that's also important because what is not included in this new development are things such as non-vehicular pathways, such as bike paths and sidewalks, because those are considered, non-pollutant generating surfaces. It's mostly just generated from cars and vehicles. The next term is redevelopment. And this occurs wherever you have previously paved surfaces. So it's similar to disturbance, where it is triggered when you have any construction or reconstruction on existing impervious surfaces in which the underlying aggregate or pervious subgrade is exposed or penetrated. So it excludes activities such as code planing, any pavement overlays, and other pavement preservation treatments such as slurry seals and crack sealing. So we'll just run through a quick example of those initial topics. So when do you determine, or how do you determine when post-construction BMPs are required? Okay, so for this example, assume that we are on the island of Oahu, such an NS4 permit area. In our existing condition, we have a 4-lane highway with grass shoulders on either side. And our proposed condition is going to be to reconstruct 1 lane, which is 1 acre, provide a new lane, which is 0.75 acres, and also use this area on the side for staging. It's going to be a disturbed area, and that is going to cover 1 acre. So under the new criteria, any disturbance of 1 acre or more, you're required to implement LID BMPs. Okay, so total it up, and you have 2.75, so LID BMPs are required. Some things to point out. So if this were a project in a non-M4 permit area, no BMPs would be required because your new impervious area would be less than 1 acre. And also, if you were designing to the current manual of 2015, this project would also not trigger because you're still under that 1 acre of new impervious area. Okay, so things like this where we have, disturbance is the trigger now. We hope to get more projects that will put more BMPs in the ground. Another thing to note is that some projects which are phased or part of a common plan of development, you also need to consider, the total area. So if you're doing, say, 1/2 acre of disturbance for this current project, and this project is going to be followed up by a second phase that's going to disturb another acre, you need to consider the total development area, total disturbance, and that will determine whether you need to install BMPs. And then once you know that BMPs are required, how much treatment will be required. So this equation has a lot of variables in there, but it basically comes down to 3 components. The first one is the new development. So you're treating any new impervious surfaces. The second component relates to the redevelopment. And John mentioned briefly what this is. So you have, because redevelopment, you already have existing pavement. So the impact to the water quality is not as significant because it's already existing, as opposed to constructing over existing pervious surfaces. So for that reason, we are allowing a factor of 25% treatment for redeveloped areas. For non-MS4 permit areas, they do not factor this in. So for non-MS4 permit areas, they only deal with the new impervious areas. And then this last component is, any areas that are treated by existing BMPs. Just to point out that this is not an automatic, credit, but this is something that will need to be negotiated with DOT, because it's not very simple in terms of, taking an existing vegetated swale and taking credit. There's a lot of considerations that need to be taken into account. But maybe in some areas where it could be considered would be if there is an existing detention basin that is oversized, then perhaps we can use some of that size as a credit. And, we had on our team, the developers of the manual, some people from the mainland, from Virginia, Maryland. And so they have a lot of experience, and the programs on the mainland are a lot more advanced, and they have decades of monitoring, and they can track or have a pretty good idea of how much specific pollutants have been removed for a given BMP. So we're trying to move in that direction. We're not quite there yet. So, this placeholder, this credit for existing treatment is like a concept, and we'll continue to develop that as the program develops. But it's going to be something that needs to be, requires DOT consultation. Okay, so going back to this problem, so we have, how much treatment is required? So we have the reconstructed lane, which is 1 acre, new lane, which is new impervious surface of 0.75 acres, and you have a little chalkboard on the side explaining what those variables are. You plug in chug, and you get your required treatment area of 1 acre. And so more detailed examples will be provided later in the workshop. Okay, so that just covers the basic criteria. So some of the changes that were made to the manual for the planning phase. So some projects that DOT puts out has a separate planning phase prior to the design phase. And so separate post-construction BMP planning reports are no longer required. We thought that was redundant. So if your project does have a planning phase and it has a requirement to provide a planning report or an EA or EIS, then you can use those reports to include information for your proposed post-construction BMPs. And, because it's so early in the game, just be just things that you take into account. It's always important to factor it into your project as soon as possible, because, a lot of these BMPs do take a lot of room, so it's good to factor that in, whether it's a roadway realignment or new pavement. If your project does not include a planning phase, then your BMP information would be provided in your post-construction BMP design report, which is provided during the design phase of your project. And so some things to include in your post-construction BMP planning report. Information would be your descriptions of your BMPs, whether you are in a TMDL or WLA watershed, any right-of-way requirements, maintenance requirements, and it's anything upfront because it's so early in the game. It's anything that you would know at the beginning. Knowing what watershed you're in, if you're a sensitive watershed, how much space that you have available. So those are all information that you should have during the planning stage, and that would help to at least shape or provide a schematic concept of what you could do for BMPs. Okay, so also include any drainage maps, proposed locations for BMPs, just to make sure there's enough physical space, any flood zones, as well as background calculations. So any hydraulic calculations, any BMP sizings, and also site photos. Photos are always helpful for the DOT reviewer to get an idea of what the challenges may be for that particular site. For the design phase, we also made a few changes. We have provided more definite requirements for infiltration testing. What we try to do is, because we know that a lot of the designers for DOT projects also work on city and county projects and other county projects, we try to provide consistency where we could between the two, between the city manual and this DOT manual. So for example, infiltration test requirements for infiltration basins and infiltration trenches, we kept the same requirements in terms of spacing. We do have a minimum safety factor of 2. And this safety factor is mainly to account for, reduced infiltration over time. So whatever your measured infiltration rate is, divide that by 2, and that'll give you your design infiltration rate. The BMPs that are provided in the manual are just a sample of, some of the devices that may be more appropriate for Hawaii. But if there are others that you've heard of, or as other new technologies become available, those are always, open to being used in your design, as long as you have some information that you can provide to DOT, such as, the type of device, as well as expected pollutant removal efficiencies. And a requirement is also for verification by established organizations such as the New Jersey NJCAT, as well as the Washington State TAPE programs, as well as warranty information that's important for long-term maintenance and O&M requirements. Another change is an updated post-construction BMP design checklist. A checklist was issued, I believe it was October of last year, which updated the current checklist in the manual. The checklist that is in the current manual has been updated again, and that's based on some feedback that we received from DOT as well as some users. So we're trying to make it easy to navigate through and make it more of a yes and no, so you can follow from one step to the next. And these checklists are mainly for, documentation for the reviewer to know in a snapshot what the project consists of, and then also for future compliance. So because every project that DOT reviews will require this to be submitted, they'll have a stack of these that they can go through, and they'll know after in 1 year how many projects were reviewed how many of those projects required BMPs. Because this current manual has a separate criteria for MS4 permit areas as well as non-MS4 permit areas, they do have separate checklists. So when you are working on a project, make sure you fill out the correct one. And then for projects that are not able to meet the full required treatment, we have this new form. It's for a variance request. And I'll go into more detail on that later. Okay, so the post-construction BMP design checklist, they should be submitted with your first design submittal. So whether that is your 30% or if you have 60%, submit it at that time along with your plans. And then resubmit the checklist at any subsequent submittal if you have any significant changes, such as if your disturbed area changes, or if you're adding more pavement or affecting the drainage patterns. And once again, that's just so that the DOT reviewer can have a current one so that they know what the project entails. The manual also updated Appendix A, which are the treatment control BMPs. So we highlighted some of the features. We have an updated summary table and also a revised each BMP fact sheet. So the summary matrix looks like this. And because we are prioritizing LID, we have that listed at the top of the table. And these are broken down just by, some of the most common BMPs. And then we also highlighted some of the most, pollutants that are expected to find. So those 6 are sediment, nutrients, oil and grease, metals, trash, as well as bacteria. And so this is just a general, because every BMP may perform differently under different conditions. So this table itself is generated from, a lot of different other manuals, a lot of different research papers. And it's hard to compare, apples to apples because they have some studies will focus on certain BMPs. And we couldn't find any really composite report that had side by side. So a lot of these are, just in general nature. If you have a project that, is off of a freeway, you may have trash, or you may have oils and grease, you can focus on those BMPs to use. But if you do have other information, or based on your experience as a designer, you can definitely incorporate that into your design as well. And this is a list of the BMPs that are covered in the manual, which includes your LID, the traditional non-LID, and then also your proprietary manufactured devices. Okay, and they generally fall into categories, either volume-based or flow-based. And so volume-based BMPs incorporate storage to achieve water quality through retention and infiltration of stormwater runoff. Some examples are wet ponds, wetlands, infiltration, as well as retention facilities. Flow-based BMPs, they provide treatment as stormwater passes through either a filtration media, or there's also some infiltration that results, as well as sedimentation. Some examples are buffer strips, vegetated swales, and media filters. Okay, so this equation stays the same. Water quality volume is dependent upon several variables, including your 1-inch storm, which is the runoff depth from the 85th percentile 24-hour storm. And once again, because this manual focuses on impervious areas only, the area that is used for this equation is only impervious areas. It's not your drainage, not the drainage basin. So because of that, your runoff coefficient is going to be higher. So although you have a smaller area that's factored into your sizing, because of your seed factor is higher, it's kind of a wash. And same goes for your water quality flow rate equation. So same equation as before, it uses your 0.4 inches per hour for rainfall intensity. But your treatment area, again, is for impervious areas only. Okay, and then keep in mind that, you know, your whatever BMP that you do choose also needs to be sized to handle, you know, hydraulic peak flows as well. Okay, so next up, we're going to go through, we have 3 examples that we put together. And the first one will cover a public project that is completely within the DOT right-of-way, and it is located within an MS4 permit area. The second example will be a little bit more complex. It's a public project within DOT right-of-way. In this one, we're gonna go through some, I guess, calculations, and the result is going to be alternative compliance will be required. And then the third one would be for a private project, which is partially located within DOT right-of-way. Okay, so here's the math portion of the class. So your engineers can take out your calculators, take out your thinking caps. Okay, we're going to cover, for example, number 1, disturbed areas, required treatment area, as well as the selection and design of a post-construction BMP. So for this one, we're going to assume a bioretention facility. And then we're also going to complete the post-construction BMP design checklist. Okay, so this is the same example as before. So hopefully everyone should get this correct, right? So MS4 permit area on Oahu. So same condition, we have a 4-lane highway. I did add a guardrail in this project, so we're going to talk about that later and how that factors in. So reconstructed lane for 1 acre, new lane, new impervious area is 0.75 acres. Staging area, which is disturbed, right? So total disturbed area, once again, 2.75 acres. Are LID BMPs required? Hopefully you got this correct because it's the same example as before. And then what do we need to size it for? Okay, so we have a 35-foot wide shoulder. That's also important. Okay, so 35-foot wide shoulder. Going through the numbers again, required treatment area, once again, is based on 3 components. Your new development, which is your new impervious, so 0.75 acres. Your redevelopment, which is 1 acre. And because we are on Oahu, we get to apply this factor, 25%. So we're required to treat 25% of that 1 acre. And then for this example, we're assuming that there's no existing treatment that we can claim credit for. So 1 acre of required treatment area. Okay, so we go to the matrix summary in Appendix A. And we want to prioritize LID BMPs, which are at the top. Because we're on a roadway, we assume that we have metals, oils, and grease, some trash. So for this example, we're going to focus on a bioretention facility. Okay, so this is the clip sheet of the fact sheet for bioretention. So at the top of each fact sheet, we do have a summary of the targeted pollutants. So this is duplicate of that matrix, but it's just provided for this specific BMP. There's also some other information provided for construction costs, maintenance costs, as well as effective life. And these are based on some manuals. You know, depending on your situation, of course, results may vary. For each fact sheet, we do have some limitations that should be considered during the design phase. For example, for a bioretention facility, we do have restrictions in terms of where they can be placed. So they should not be placed in locations that cause water problems to adjacent properties or roadways and should be set back 10 feet from any structures. Because they are, subsurface treatment, also need to provide 3-foot clearance between the bottom of the facility and the groundwater level. And then each fact sheet also has design criteria with examples, step-by-step examples. And the sizing procedures that are provided are just general in nature. So they do allow for some flexibility based on your experience. And for some of these, we try to stay consistent again with city guidelines as well. We want to make it easy for designers as well as the contractors. If it's something that they are familiar with, there's less chance of errors. Okay, so step 1, determine your water quality volume. So we do have your treatment area is once again focusing on your impervious surface, which is 1 acre. And because it is focusing on your impervious surface, your runoff coefficient for paved surfaces is 0.95. And so all of you that have your calculators handy, you can punch that in. And 3,448 cubic feet of water quality. And you're an engineer if you have your calculator and you're punching it in, so you know who you are. So hopefully, if I do have a mistake in here, let me know. Okay, so for some of these BMPs, look at pretreatment. If you can squeeze in pretreatment, that'd be great because they do capture sediment that may otherwise shorten the life of your BMP. They also help to reduce incoming velocities and also provide some storage. So it could be something as simple as the picture on the right. It's just a little depressed area, but it does provide capture for some sediment before it gets into your system. For whenever you do provide a pretreatment volume, it's sizing for 10% of your water quality volume. Your pretreatment may also come in the form of like a filter or screening. In those situations, you will not be sizing it based on the volume. We're following through the calculations here. So 10% of your water quality volume gives you a pretreatment volume of 344 cubic feet. And your volume for pretreatment does count toward your water quality treatment. So the remaining treatment that is required is going to be your original water quality volume of 3,448 minus your pretreatment volume. So your actual bioretention facility needs to be sized for 3,103 cubic feet. Okay, and then the steps to design the bioretention. Calculate your maximum storage depth. We have on the screen typical values as well as what we assumed for this problem. So 4 inch per hour for infiltration rate, a drawdown time of 48 hours, and then a factor of safety of 2, the infiltration rate. So plug and chug to get you your maximum depth of 8 feet. And then next you calculate what your total effective storage depth, which is what your actual design is based on. You're going to have different components that you have to factor in. So your first one is, what is your maximum planting depth? So typically we allow 6 inches. Next is going to be your planting media, anywhere from 2 to 4 feet deep, porosity of 0.2 to 0.35. For this example, we're assuming a 3-foot depth and a porosity of 0.3. And then the drainage layer on the bottom, anywhere from 8 to 12 inches. We're assuming 12 inches for this example, and a porosity of 0.4. So when you plug those numbers in, you get a total effective storage depth of 1.8 feet. which is less than your maximum storage depth. So we're all good. And to size your bioretention, we're going to assume it's a rectangular facility. So to calculate your bottom surface area, use this equation. And for this one, we are assuming the pretreatment is part of this. So we have that 0.9. If you do not have pretreatment as part of your bioretention, then you would not have that 0.9. You would need to size it for the full water quality volume. Okay, so we have a fill time of 2 hours. Infiltration rate factor safety is 2. I think that's the typo, sorry. Infiltration rate should be 4. That's shown in the formula. So your area of your bottom surface area should be 1,454 square feet. Okay, so step 6. So determine what your bottom width will be. And this is important. So for DOT, most of the times you're limited in the corridor, so you don't have a lot of space on the side. So for this example, it's 35-foot shoulder. And if you remember, we have a limit of 10 feet distance from the roadway, 10 feet from property lines. And so the actual available space is just a 15-foot max. And then this 15-foot max, the clearance is measured from the edge of the high water level. So if you look at the 6-inch ponding depth and where that would extend to, that is where your actual clearance is measured from. So to calculate what that is, you have your 15-foot max. And then you factor in your side slope. We're assuming a 3-to-1 side slope with a ponding depth of 6 inches. So your top width, so your bottom width is going to be 12 feet. And then to determine your bottom length, this is probably the easiest calculation you'll do all day. It's just your area divided by the width. So for a 12-foot width, your required length would be 121 feet. Okay, so now to calculate what the top surface area is, this is important because this is where you may run into physical constraints. So you need to see what the actual size is of your BMP at the surface. So using this equation, factoring the same side slopes of 3-to-1, your bottom length as well as your bottom width, we have a freeboard requirement of 1 foot. And that'll give you a top surface area of 2,735 square feet. Okay, so there it is. So it's gonna squeeze in right in the shoulder. And here's a picture of our designs, the bioretention with a 6-inch ponding depth, as well as a planting media of 3 feet. The rock storage layer of 1 foot. For this example, we have an under-drain pipe. We don't have a requirement for under drains, but that is subject to your experience. We know that for some areas, if you have a high infiltration, under drains may not be needed. If you do have clay, or if you do have a large area, under drains help to spread out distribute the flow within the bioretention facility. So we'll leave that up to the designer to decide. We do give some guidance within the manual. Okay, so the next step is to fill out the post-construction BMP design checklist. So make sure you grab the right one. This is for MS4 permit area. Fill out your watershed as well as your disturbance area, how much impervious area is being created. And then the applicant name, make sure that whoever fills it out and whoever is listed on here is someone who's knowledgeable about the project, because if the DOT reviewer has any questions, they're going to call this person. So it'd be good to know, who actually designed it, and they can actually, talk to them directly about, what assumptions were made, and get more information about the project. The step number 1, this is for projects. It helps you weed out projects that may be exempt from post-construction BMPs. And so we've gotten some comments. We're trying to make this clearer. So just to be clear, only fill this out if your project only includes these repairs. So for example, our project did have a guardrail installation. Okay, but because we also had a new pavement area, do not check this box. You would only check this box if your project only consisted of installing a guardrail. Or, our project, you would have, temporary BMPs. Do not check this box because it does include other activities that are not exempt. So only check these boxes if your project only consists of exempt activities. Another thing to point out is, at the very top, so if your project does not result in stormwater discharge into the NS4, you're exempt. So keep in mind that the NS4, includes any swales, gutters, any ditches, or any runoff into state DOT. So it's not just into, into a catch basin or into a pipe system. It's any surface water as well. Okay, so if you do have a project that only includes exempt activities, then you can continue to step 7. Otherwise, we'll continue on. So we have step 2. So is your project a private construction project? This one is not. We continue to step 3. And does your project result in 1 acre or more of disturbed area? Yes, it does. So LID BMPs are required. Continue to step 6. Does your project treat the full required treatment area? Yes, it does. So you continue to step 7. And this is where you need to provide your signature and date. So although it says additional project information is optional, the only thing that's optional is if you wanted to add more information about the project, but providing your signature and date is required. Okay, so once you submit it to DOT along with your project submittal, they'll review it. And then there's 3 options. So either the project does meet the full required treatment area, or it's designed to the MEP. The second option is that no, your project is not designed, and you will need to provide additional BMPs. The third option is no, your project will result in a debit, and alternative compliance will be required. Okay, so those are the 3 options for the DOT reviewer. Okay, so moving on to design example number 2. So this is for a public project, still within DOT right-of-way, and it's for a permit area. And this one will have alternative compliance. So we'll again look at computing the disturbed area, required treatment area. And then we'll also look at selecting LID BMP, which in this case will be an infiltration trench. And then a non-LID, which is a hydrodynamic separator. And then computing the deficit amount of the treatment, and then how do the process involved for applying for alternative compliance. Okay, so we have our existing condition is where we left off from our previous example. So this is 10 years down the road. We have 5-lane highway. We still have our existing bar retention that was constructed earlier. Okay, so proposed condition, they want to add a new lane. So there's going to be a new lane, 2 acres of new impervious surface. A staging area, which is disturbing pervious area of 0.5 acres. So your total disturbance for this site is 2.5 acres. So LID BMPs are required. Okay, and then we go back to the equation to compute the required treatment area. So 3 components again. It's based on your new development, redevelopment, and any existing treatment. So new development of 2 acres. For this example, there's no redevelopment, so that is 0. And then although there is an existing bioretention, because it's on the other side of the road, we're assuming that it's beyond the drainage of this new improvement. So area for existing treatment is 0. So required to treat 2 acres. Okay, we're going to do infiltration trench. The sizing for an infiltration trench is similar to a bioretention facility. So use the same equations. Once again, impervious surfaces only. C factor of 0.95. Gives you a water quality volume of 6,897 cubic feet. For this example, again, we're going to have a pre-treatment area, which will be sized for 10%. And so your remaining volume for your water quality volume will be 6,207 cubic feet. Okay, maximum storage depth again, same equations. And a max depth of 8 feet. For this equation, it's a little bit different because for an infiltration trench, there's no ponding. So there's 3 components to this formula. You're going to have your top aggregate layer. For this one, is typical. We're using a 6 inches with a porosity of 0.3. Your rock storage layer below that, typically 2 to 10 feet. We're assuming a depth of 3 feet and a porosity of 0.3. And then a sand layer on the bottom, assuming a 12-inch. And the sand layer is mainly to assist when you have to maintain it. So as any pollutants, particles get caught, it does get caught in that sand layer. So it's easier to clean out versus if it wasn't there, then you'd have to probably dig below the subgrade. So calculating this gives you a total effective storage depth of 1.45, which is below your max storage depth. So we're okay again. And the required bottom surface area. Once again, because this does not have a ponding depth, we do not need to include the top slopes. So it's only the surface area is only for the bottom of the infiltration trench itself. Okay, so it's water quality volume. Take 90% of that because we do have pretreatment. A fill time of 2 hours. This is kind of like an industry standard, and that 2 hours is based on studies that have been done on how long it takes to fill a facility based on your inflow, plus you have the rainfall over the size of that facility, as well as some outflow. So 2 hours of fill time, and then a factor of safety of 2. So your area is 3,480 square feet. Calculating your length and width. 12-foot assumed bottom width gives you a length of 290. Okay, so now we got to go back to the site. So can we squeeze this in? So we have a required length of 290 feet. However, for this site, assume we have, say, protected trees or a structure or light poles that cannot be relocated. So due to site constraints, the longest length that we can fit is a 100-foot infiltration trench. So in this case, what we need to do is do some back calculations to see how much treatment is provided with this 100-foot length. Okay, so using the same equations, just have to rearrange the variables. So for the actual BMP, it's going to be 12 foot wide, but because we can only squeeze in 100 feet, The BMP itself is a 1,200 square foot. And then that provides a water quality volume of 2,377 cubic feet. And so how much additional treatment is required? Okay, so going back another step further, we do have the water quality volume provided by the trench, infiltration trench. Once again, it's 2,377. So that corresponds roughly to a treated area of 0.69 acres. If you remember, the required treatment area for the whole project is 2 acres. So we do need to provide another 1.31 acres of treatment somewhere. Okay, so for this example, we're going to try and squeeze it in. So things to consider. So what type of additional treatment can you use? Right, obviously space constraints. If you didn't have room for an infiltration trench, you know, possibly there's another type of BMP. A lot of the manufactured treatment devices do have a smaller footprint, so they may be able to be incorporated into your design. Another factor to take into account is, you know, when you combine post-construction BMPs, when you have a flow-based BMP as well as a volume-based, they do react differently to flow. So you need to consider that in your project. For example, you know, flow-based BMPs, they do handle, I guess, longer storms, maybe of shorter intensity a lot better. If you were to have, you know, a large peak storm that runs through there, they may overwhelm the system, and you know, a lot of the pollutants that were settled out may go back into suspension. Likewise, for volume-based BMPs, you know, they may handle the intense storms better, but over a long duration, as they fill up, they do tend to, you know, may bypass pollutants downstream. So keep that in mind and do a combination of the two. For this example, we're going to assume that a flow-based BMP will be used in this corner. And then to determine the size for that, we use our water quality flow rate equation. Because it is a paved surface, there's a table provided in the manual for a paved surface is 0.7. Rainfall intensity is 0.4 inches per hour, which gives you a requirement of 0.37 CFS. Okay, and because it's flow through, size it based on your water quality flow rate as well as your peak flow. Okay, and then for this example, you know, assume that we have the 0.37 CFS, and we're going to pretend that we, you know, look through all the literature, we look through all the vendors, look through all the products, and based on the size of the site, there's nothing that can provide that full 0.37 treatment. Okay, so the process for going through your design, you do LID as your priority. If you can't meet the full treatment with that, then you go to the non-LID option. And if that is not enough to treat the full area, then you're going to be using alternative compliance. Okay, so whenever you can't treat the full required treatment, the next step would be to fill out your design checklist. Once again, only fill this out for exempt activities. For this project, we are still in, it's a public project. We have more than 1 acre. We'll go down to step 6. Does the project treat the full required treatment area? We need to check no. So the acceptance of the water quality treatment to be determined pending DOT-HWYS review. So we need to submit a variance request form. Fill in your signature. And then for this one, the DOT reviewer would check the last option. So the project does not meet the required treatment, and so alternative compliance will be required. Okay, so the variance request form, the information at the top is a lot is the same in the post-construction BMP checklist. Provide, justification on why the full treatment cannot be met, whether it's a physical constraint. The manual also provides a list. Section 5.2 provides different types of constraints that may be encountered: hydrogeological, if there's high groundwater; physical, operational, if there's no room at the site. You have to think about long-term maintenance. You want to make it easy for maintenance crews to come in. If it's in the middle of a traffic lane, that would require them to shut down a lane of traffic. And also environmental or cultural things to consider, whether you're disturbing an area with known archaeological findings. A lot of this is going to have to be provided. If you do have information, you provide it in this space here. And, this is just to help the reviewer to get a better idea, a complete picture. So the more information that you can provide, the better. And list, if you're going to provide, drawings, calculations, photos. And then the DOT reviewer will check whether your variance is approved. If it is approved, it's either to say that although the required treatment is not met, it has been fulfilled to the maximum extent practical with the MEP, or this box would be checked if they're saying that not enough treatment is provided, but we will look at an alternative watershed. If they do check on the denied box, what that means is that the designer will need to go back and either look at a different type of BMP or resizing it, or that'll be further conversation with the reviewer. Okay, but the denied box basically means that, they think that other options may be better or may be able to provide more treatment. So that will require going back to the drawing board and redesigning. Okay, and then the last example for today, private project partially located within DOT right-of-way. So these situations don't come up very often. They're, mainly because if you have a new residential subdivision or a shopping center. So it does require, coordination with the designer. They have to look at the work within the DOT right-of-way as well as outside of DOT right-of-way. So for this example, we're not going to go through any real calculations. This is more just explaining how DOT will approach this type of project when it comes in for review. Okay, so for this example, we have an existing condition on the top, undeveloped private property. The yellow line represents the property line, and it is adjacent to DOT right-of-way. Okay, so proposed condition is for a new development, and to access this development, the developer proposes to add a turning lane, which is within the DOT right-of-way. So there's going to be obviously some disturbance, new impervious surfaces within DOT right-of-way. And what's on the screen right now is the criteria. Yeah, so post-construction BMPs may be required at the discretion of DOT-HWYS, regardless of the project size, for private construction projects located within the DOT-HWYS right-of-way, if the project has the potential to discharge stormwater runoff to the DOT-HWYS right-of-way. And private construction projects located outside the DOT-HWYS right-of-way are considered to be in compliance with post-construction BMP requirements if the project complies with the stormwater quality requirements of the applicable county. Okay, so for this example, are post-construction BMPs required? And that depends. So because each project is different, each situation is different, we can't provide a simple yes or no. But these are things that you should consider and that the DOT will also look at once the project comes in for review. So some factors to consider. Yeah, so what is the total disturbance area? And this is the total disturbance, not just in the DOT right away, but for your whole development. So if your whole total disturbance is over an acre, then the project will be evaluated for post-construction BMPs. Okay, and how much new impervious surface is created. Even if it's less than an acre, DOT may require treatment regardless of size. So every case is different. And where is the runoff directed? If it does flow into DOT right away, then definitely it will be evaluated for post-construction BMPs. If somehow the runoff is directed into private property, it completely remains outside of DOT right away, not in the NS4, then post-construction BMPs would not be required for DOT right away. Okay, and also there an increase in runoff quantity. So even though there's maybe no new impervious surfaces, if there is, grading, or if there's, resloping of that portion within DOT right of way that results in an increase in flow, then that may need to be considered, or it needs to be considered. And if the project is located within a sensitive watershed, even if it's less than an acre, BMPs may be required, and that's just because of waste load allocations, any type of discharge limitations that may be imposed. And most importantly, so as long as the project does comply with the county requirements, John mentioned that before. So whether it's a water quality report, make sure that that report does cover any flow that does go into state right away. Make sure it covers both, so that the DOT reviewer can look at it and get a complete idea of the project. And as long as the project itself does comply with county requirements, then DOT is willing to accept that as satisfying the post-construction BMP requirements. Okay, so that's kind of a run through. At this time, I'll hand it back over to John, and he's going to go over some requirements for maintenance and operations.
Yeah, actually, I'm going to go ahead and give us another little break. Let's reconvene. I guess these are going to be 7-minute breaks today. We'll reconvene at 10:20. And I'll go over some operations and maintenance stuff that's in the manual. And then after that, we're gonna look through some of the questions that have been submitted. And if there's some that we feel like we can answer fairly straightforward, we'll go ahead and answer those after we're done with the operations and maintenance portion. And then, like mentioned earlier, we're gonna give you an opportunity to submit more questions if you think of them after the workshop, and any other questions that we got during the workshop that haven't been answered, and we will answer those next week at the session on the 25th. Okay, so we will see you in a little bit here at 10:20. So this is a bit of an unpleasant slide, and it has a lot of text, but just going to grind through it. So inspections, operation, and maintenance. So there's a couple components of that. One is inspections during construction, and these are very important to make sure that these post-construction BMPs and LIDs are actually installed properly. Because as with most other underground utilities, once it's buried, you can't tell if it was installed correctly. So you need to be able to confirm that these structures are in the ground properly before they get buried. So during excavation to subgrade or subfoundation, especially for infiltration facilities, to ensure subgrade remains uncompacted. During placement of underdrain systems and observation wells, you want to make sure those are connected properly, that the pipes aren't damaged, that if they're like a perforated pipe, they're not being filled in with sediment. During backfill for foundations, trenches, underdrain systems, and observation wells, A lot of this stuff can easily get damaged during the backfill process, so they need to be inspected during backfill, during placement of geotextile and filter media, during the placement of structural fill beneath drainage structures, during construction and installation of components of the treatment process, such as diversion structures, pre-treatment forebays, inlets, outlets, media filters, overflow pipes, outfalls, and flow distribution structures. And then upon establishment of permanent stabilization, during vegetative planting and plant maintenance, so that'd be for your swales, your grass swales, and even your enhanced bioswales that have a vegetative component, and at any critical construction stage highlighted by the manufacturer for proprietary treatment control BMPs. So most of these proprietary BMPs, they provide their specifications, and their inspection requirements would be included in there. And just to give you a little peek at some of the issues we've encountered, this is a enhanced or bioswale that was being constructed along H3. And so you can see this is the aggregate rock layer going in. So something that occurred shortly after this phase, while this aggregate rock layer was still exposed, was a large storm event came and filled in this rock layer with a lot of sediment. And so it basically became unfunctional and had to be re-excavated and redone. So if that hadn't been caught, that obviously would have reduced the function of this and the capacity of this bioswale. Here's the construction of a DSBB debris separating baffle box. This one had a lot of groundwater issues, and so they had to figure out they had to end up using some sort of water block geotextile in order to make sure that this box wasn't going to be constantly infiltrated with groundwater. But you can see, and also you want to look at, is the integrity of this pipe good enough to handle the construction and installation of this box? And you can see over here, once the box is in place, you can see where it's in this pipe gap and then discharges to the channel here. The next important component, of course, is long-term maintenance. And the long-term inspection, operation, and maintenance requirements need to be included in the Stormwater Post-Construction BMP design report. And we're looking for stuff like inspection frequency, maintenance threshold or frequency. So often the maintenance isn't required until the BMP meets a certain threshold, like if a baffle box is filled to a certain depth or a CDS unit to a certain depth. Stuff like LIDs are going to have more of a custom operation, inspection and operation maintenance schedule that's based on the specific design and specific location. And then also we want to know maintenance equipment requirements. There are some structures that require the use of a vac truck, and that's important to point out in the maintenance requirements, and then also your estimated maintenance costs. So we also want you to be really thinking about how these things are going to be maintained during design of the project. If you can see these 4 manholes right here, this is a nutrient separating baffle box that was constructed along Kamehameha Highway in Kaneohe. And hopefully you can see the problem here. All these, the location of this box is right at the edge of the travel lane. So the only way this box can be inspected is by implementing traffic control. We really want to avoid scenarios like that. A couple other considerations is just inspection and maintenance access. On the left here, you can see a baffle box that was installed with these very, I think these are 54-inch, extremely heavy manhole lids that are rated for traffic loading. However, this box is actually located behind a guardrail and is elevated, so it is not going to have anything driving on it. And a much more suitable design would be like this one over on the right, which is also located behind a guardrail and will not be driven on. And we instead use these hatch systems that are much easier for our inspectors to access and also much easier to access for maintenance. And that's all I've got for maintenance. Someone have a question? Okay, no questions on maintenance that I see. We're going to go ahead and try to answer a couple of the questions that came up during Jason's session, but also I'm providing you this email to Ben Phillips, who works with me at ETC. And if questions come up after the workshop that you didn't think of during the workshop, you can feel free to email him. We just ask that you send us those emails by the end of the day, Friday, May 20th, and we will do our best to answer those at the follow-up session on the 25th. And also, one more reminder, when you do sign off the webinar, make sure you provide your name and email if you want to be invited to that follow-up session. All right, Jason, you ready to dive into some of these questions?
Okay, let's tackle, Miley had a question about whether a raised bike lane and sidewalk and road widening is included. So although you do need to consider the total disturbance area. So, you know, because you have to disturb areas to construct a sidewalk, that's included in your disturbance area. And then that dictates whether BMPs are required, but then it is not included in your required treatment area. So you're only required to treat the portion that is the road widening area. So hopefully that answers that question. There's another question from Jeremy that I see. So can the credit be used for other nearby projects, or does it only pertain to the specific project that obtained the credit? What can the credits be used for? So I can't recall if it was mentioned in the presentation, but the credits are based on, they're tracked per watershed. So if you do have a project in a certain watershed that results in a credit, then that credit stays in that watershed. At least that's the way that we are approaching it for now, so that if you have another project that comes along in that same watershed that is not able to meet the treatment, then because you do have a credit available, that credit would offset any debit within that watershed. So credits are tracked per watershed, and it's just tracked for future projects.
Okay. I do see someone tried to raise their hand a couple times. If whoever that was, if you can actually type your question into the Q&A, that would be helpful for us.
Okay, question from Dwayne.
Yes.
So to confirm, so there's a private project where a portion of the construction is within the right-of-way, and the flow from that portion flows to the DOT-HWYS. If the area within the state DOT right-of-way is included with the calculations for the private project area and addressed for the city's stormwater quality report, and post-construction BMPs is not required. So this we may have to defer to DOT. I think each case is on a case-by-case basis. I think it depends on how much flow.
I can say in general, we did have this scenario, and it was a small enough section of flow that we did allow the additional stormwater to be treated on site. In that particular situation, the storm drainage that went off of the site into the city storm system eventually reconnected back to DOT's system. So in that case, it made sense to allow for all the treatment to occur on site. But again, when these circumstances come up, we're going to have to take them on a case-by-case basis. But the goal is definitely, as much as possible, is to try to address private projects within the private footprint and within the city and county's design report. Okay, I think that's all we have for now. Okay, well, I don't see any more questions popping up in the chat or the Q&A. So with that, I'm going to dismiss us. Unless Karen or Jason, do you have anything else to add?
No, I just want to thank everybody for listening in. Thanks for your time.
Yep. Oh, here we go. Oh, I got the question, sorry, will the recording be published? Eventually this recording will be provided, most likely on the Stormwater Hawaii website, and we'll let you know for sure. That's another thing, if you provide us your email, we'll send you follow-up information. We'll put you on a list to send up any follow-up information about the manual in general and about the workshop content.
I just want to thank you and all of the attendees for attending, and look forward to next week, Wednesday's presentation as well.
Yep, thank you, Karen. I did just get one more question. Is the stormwater post-construction design checklist for non-MS4 areas the updated version of the stormwater control design checklist tool? And yes, that is correct. Both of the checklists included in the new manual will replace the old version that was called the stormwater post-construction design checklist tool. Okay. All right, I think that's it. Thanks again, everybody, for attending, and we look forward to working with you on implementing the new manual and getting more treatment out there to protect our stormwater.